Hi everybody, today we're going to be doing lesson 103, finding the least common multiple of two numbers. So first let's talk about what a common multiple is. A multiple is a number that a factor will go into. So for example, the multiples of 4 are 4, 8, 12, 16, 20, 24, 28, etc. The multiples of 6 are 6, 12, 18, 24, 30, and so on. So a multiply is a number that you can multiply with something to get a number. So 4 times 1 is 4. It's a multiple. So a common multiple are numbers that two numbers have in common. So the common multiples of 4 and 6 are, let's see, 4 is not in common, 6 isn't in common, 8 isn't in common, but 12 is a common multiple. 24 is a common multiple. If I was to keep going, here I have 36, here I have 32, and then 36. So 36 would be a common multiple. Today we're going to talk about finding the least common multiple. So the least common multiple, or LCM, is the smallest number that both factors go into. So for this example, 12 is the smallest or the least common multiple of 4 and 6. So let's look at the LCM, or the least common multiple, for 7 and 9. Okay, 7 and 9. So the first thing we need to do is we need to list our multiples, which basically means we just list all of the numbers that 7 and 9 go into. So 7, 14, 21, 28, 35, 42, 49, 56, 63, and then 9. 9, 18, 27, 36, 45, 54, 63, 72, 81. So looking at this list, the first number that both 7 and 9 go into is 63. So 63 is the least common multiple, 63, of 7 and 9. Okay? But there's got to be a little bit of an easier way to do this, okay, rather than writing these all out. But let's do another one first just to make sure. So let's go on to example 2, which says find the least common multiple of 6 and 8. So again, we're going to write our list. You can write it horizontally or you can write it vertically. I'll write this one vertically just so it looks a little bit different. So we have 6, 12, 18, 24, 30, 36, and we'll stop there. 8, 16, 24, 32, 40, and I can see that I already have a number that is in common. So my least common multiple of 6 and 8 is 24. Okay? Now, they have more multiples in common, but we're looking for the smallest, or the least common multiple. Okay? Now, some of you might be going, well, if I multiply 6 times 8, it equals 48. So therefore, that must be a common factor. And it is, you're right. If my list kept going, I would get to 48. However, 48 is not the least common multiple, or the smallest. It's 24. Sometimes when you multiply two numbers together, that will be the least common multiple. Other times it won't, so you need to make sure that you make your list. Okay, let's look at example 3. Find the least common multiple of 5 and 15. Okay, well, you should probably already be able to guess by now. We're going to make our list, 5, 10, 15, and we go, hey, look, that's one of our numbers. If I start with 15, my first multiple is going to be 15. It is possible that the least common multiple will also be one of the factors. It will never be less, but it could be one of the factors. So the least common multiple does equal 15. All right, example 4. We're going to change gears a little bit here. This time we want to use prime factorization to find the least common multiple of 14 and 18. So we're going to make our factors. We've got two ways. First is our factor tree. Remember those? Okay, what multiplies to find 14? And we have 2 times 7. When we get to a prime number, we circle. So the prime factorization of 14 is 2 times 7. Okay, we have 18. 2 times 9 equals 18. 2 is prime, so we circle it, but 9 isn't, so we move on to 3 times 3. 3 is prime, we circle both of those. So the prime factorization of 18 is 2 times 3 squared. You're going, okay, great, now what? Now, oh, excuse me, thought I had to sneeze. Okay, now we are going to use these to find our least common multiple. So we're going to take the 2, okay, because there's a 2 in both numbers. We're going to start with our 2, and then we're going to multiply times 7. Nope, scratch that. 2 times 7. And then, so we've used this prime factor, this prime factor. This 2 is already accounted for because we have a 2 over here. And now we're going to use the 3 squared. 3 squared. So 2 times 7 is 14 times 3 squared, which is 9. And 14 times 9, we of course move off to the side and show our work. We don't do it in our heads. 4 times 9 is 36. Carry the 3, 9, 10, 11, 12. So 126 is the prime factorization. Okay? We only use one of the 2's, even though it appears in both the 14 and the 18, we only use it once. Okay? We only use it from one of the factors, not from both. All right? So let's do another one like this just so that you can get more of a feel for this whole prime factorization one. So let's try prime factors of 16 and let's use 21. Okay? So 21 is 3 times 7. So there's our prime factorization. 16, we can go a couple different routes. This time I'll do 2 times 8 and 2 times 4 and 2 times 2. So I'm going to take all 4 of these 2's and turn them into 2 squared, 2 to the 4th, I'm sorry, times the 3 times the 7 in the 21. So 2 to the 4th is actually 16 times 3 times 7. I'm going to simplify this to 16 times 21. And you'll notice with these 2, it's actually going to look like I'm going to have to multiply them together in order to find the least common multiple. This may not always be the case. 3, 6. Okay, So my answer is 336. All right, do the best you can on the lesson practice. We will review this in the morning. The lesson practice does go on to H and I at the top of page 770, so make sure you don't miss those, okay? Good luck.